All right, let's dive into something you see, well, every single day: water. But have you ever stopped to think about how weird it is? Seriously, it's like a master of disguise. It appears and disappears right in front of our eyes. So today we're going to put on our detective hats and solve some of water's biggest, most common mysteries.
You know what I'm talking about, right? A big rainstorm passes and there are puddles everywhere. But then you look again a few hours later and poof, they're just gone. It's like a magic trick. So where does all that water actually go?
And then there's this puzzle. You pour a nice ice-cold drink in a warm day, and a few minutes later the outside of the glass is dripping wet. It looks like it's sweating. Where are those little droplets even coming from?
So yeah, on one hand you've got water doing a disappearing act, and on the other it's mysteriously appearing out of nowhere. But this isn't magic, it's science. And don't worry, we're on the case. We're going to follow the clues and figure out what's really going on here.
Okay, first up, let's cackle this vanishing act. From puddles on the street to the clothes you hang out to dry, where is all this water going?
Let's think about a really simple experiment that helps us get to the bottom of this. Imagine you put just a little bit of water on a solid steel plate. Now your first thought might be that it soaks in, kind of like it does with dirt, but it's a steel plate, it's solid.
And sure enough, if you just wait a little while, that water disappears. You can check the other side of the plate, it's totally dry. So if the water didn't go through the plate, where in the world did it go? The plot thickens.
And here is our first huge clue. The answer is evaporation. It's a sciencey word, but all it means is that the water changed from a liquid, the stuff you can see and touch, into an invisible gas called water vapor. It's like it put on an invisibility cloak and just floated away. It didn't disappear, it just changed its disguise.
And once you know what to look for, you see this happening everywhere. It's why your wet clothes eventually get dry on the line. It's why the floor isn't wet for long after you mop it. It's even how our bodies cool off when we sweat. Oh, and you know how hand sanitizer just vanishes on your skin? Yep, that's evaporation too.
Okay, so case closed, right? Well, not so fast, because sometimes this disappearing act is super quick, and other times it seems to take forever. So let's dig a little deeper and see what clues tell us about what speeds the whole process up.
Our first big clue is heat. Just think of sunshine as pure energy. It gives those tiny water molecules a jolt, kind of like a shot of caffeine, so they have enough energy to break free from the liquid and zip off into the air as a gas. So more sun means a faster getaway.
And clue number 2, wind. Wind acts like a little helper. See, as water evaporates, it kind of creates this little humid bubble of air right above it. A good breeze comes along and just whisks all that damp air away, making room for more water molecules to make their escape. So we've cracked the case of the disappearing water. But what about the opposite problem? Let's move on to our second mystery, the water that seems to appear out of thin air on a cold glass.
For this one, we've got a couple of detectives on the case, Thirif and Avi. They're both looking at the same evidence, that sweaty glass, but they have totally different ideas about what's going on.
So Thirif's theory is pretty logical at first. He thinks the glass must have tiny, microscopic holes in it, and the water is just leaking out. I mean, it makes sense, right? Where else would the water come from?
But wait, Avi is a sharp observer. She points out a critical flaw in that theory. She says, look at the water level inside the glass. If it were leaking, the level would go down. But it doesn't, not even a little bit. So something else has to be going on.
And Avi is absolutely right. The water isn't coming from inside the glass at all. So where's it coming from? Well, the answer has been all around us this whole time. It's in the very air we're breathing.
And this brings us to our second big word of the day, condensation. It's the exact reverse of evaporation. Remember that invisible water vapor in the air? Well, when that gas bumps into a cold surface, like our glass, it gets chilled, slows way down, and turns back into liquid water droplets.
And you've definitely seen this beautiful effect in nature. Think about morning dew on grass or on a flower petal. As the air cools down overnight, it can't hold as much of that invisible water vapor anymore. So it releases it as these tiny, perfect droplets on whatever cool surfaces it can find. That's condensation.
Okay, so we've got water disappearing into a gas, and we've got it reappearing as a liquid. But these aren't just two random magic tricks. They are two pieces of a much bigger puzzle, one of the most important processes on Earth, actually.
So to really get the big picture, let's just quickly remember water's 3 disguises. As a solid, you've got ice, it holds its shape,
As a liquid, it flows and takes the shape of its container, and as a gas, water vapor, it just spreads out everywhere. Our two mysteries today are really just about water switching between these liquid and gas costumes.
And here is the grand finale. This is where it all clicks into place. Evaporation and condensation, they're part of a giant planet-sized cycle. The sun's heat evaporates water from oceans and lakes. That invisible vapor rises, cools off, and then condenses to form clouds. And when the clouds get heavy enough, the water comes back down as rain. And the whole thing starts all over again. It's the water cycle.
So now that we know the secrets behind these processes, let's look at how we can actually use them. It turns out this constant back and forth gives water some pretty cool superpowers in our daily lives.
Remember how we said sweat evaporating cools you down? Well, people have used that same idea for centuries to keep water cool without any electricity. With an earthen pot, a tiny bit of water seeps through its pores to the outside surface. Then, as that water evaporates, it actually pulls heat away from the pot. It's like a natural air conditioner, and it leaves the water inside wonderfully cool.
So from the fog on your bathroom mirror after a hot shower to the steam rising from your morning coffee, this amazing dance between liquid and gas is happening all the time, all around you. Now that you know the secrets, I bet you'll start noticing it everywhere. So what's the next water mystery you're going to spot?